A special relation that two or more lines can have is to be parallel or perpendicular. I think visually you understand exactly what those two words mean. So here's the mathematical way that shakes out. So here's really the definition of the word parallel. They're just parallel if they have the same slope. And I think if I asked you to guess, before you even knew, you would probably guess that about two parallel lines, that they have the same slope. Or we have to include the little caveat, or are both vertical, because remember, vertical lines don't have slope, but any two vertical lines are still parallel. So that's what perpendicular means, and you probably know that. They make a right angle, right? A 90-degree angle. So mathematically, it's not quite as simple. You might think, okay, are the slopes negative of each other? Are the slopes reciprocals of each other? Well, it's actually both. So, and this is just something you just have to remember. Perpendicular lines have slopes that are negative reciprocals of each other. Another way to think about that, if for whatever reason this makes it easier for you to remember, when you multiply their slopes together, you get -1. There are some perpendicular lines. Just to throw a random example, this line, the one that rises, obviously has slope 2/3, and this line has slope -3/2. And it's pretty easy to tell that they form a nice 90-degree angle when they meet. Two parallel lines never meet. All other lines will. Okay, so here's the kind of thing I could expect you to do. Determine whether the lines 4x minus 3y equals 7 and 6x plus 8y equals -5 are parallel, perpendicular, or neither. So the only piece of information we need to figure this out is the line slope. But we don't have it because the lines are in this wax standard form. So the easiest way to get their slope is just to pop them in slope-intercept form by solving them both for y. There's the first one, -3y equals -4x plus 7. I like to put the 4x first, and then just divide everything by -3, so you get what y equals 4/3 x minus 7/3, like so. Now, you can just do the same exact thing with the other line. So here comes line 2. Subtract the 6x, you get 8y equals -6x minus 5, and then divide everything by 8. And you get y equals -3/4 x minus 5/8. So it's almost like there's some extraneous information in this problem because the y-intercepts actually don't matter for what we're trying to do. It doesn't matter. All we need to look at are the slopes. So the first line turns out as slope 4/3. Second line is slope -3/4. Just think, okay, are those negative reciprocals of each other? Why, yes. Yes, they are. So that's it. They're perpendicular. So the slopes are either equal, or they're negative reciprocals, or they're neither of those things, which means they're just not perpendicular or parallel at all. Here's an example of something that will most definitely be on the exam. Okay, so we got to put a bunch of stuff together to do this. We're going to find the equation of the line passing through the point -2, -1 that is perpendicular to the line 2x plus 3y equals 3. Let's visualize what we're doing. That's the line 2x plus 3y equals 3. You can graph it when it's just like this if you have a computer graphing thing like I do. If you're going to do it on your TI-80, whatever, you would have to solve it for y. But anyways, that's what it looks like. That's the point -2, -1. So picture what you're trying to find before you find it. It looks like this, right? It goes through this point and it's perpendicular to this line. Okay, so here we go. So the first thing we want the slope of the new line. I'm sorry, we need the slope of the old line, right? We don't have it in its current form. So we get it by putting it in the slope-intercept form. So there you go. You would have had to do that anyway. So 3y equals -2x plus 3. Divide everything by 3. You get y equals -2/3 x plus 1. Okay, so that's just the same equation. It's just in different form for this line that we were given. So again, the only piece of information we need from that is this -2/3. The 1 doesn't do anything. Like all the 1 does is shift this line up and down. It's not going to affect like this line over here that's perpendicular to it. So we have a line with slope -2/3. We want a line that's perpendicular to it. So our new line is going to have slope positive 3/2. And now we have 1 point that we were given, and now we have our new line slope. So that's a key to you should use point slope form. Okay, so it's m, which is 3/2 times x minus, we only have 1 point, so we got to use this point. So it's x minus -2 equals y minus -1. Now, I probably shouldn't put the equation in these problems because there's a million different ways to leave an equation for a line. If I put it like this, then you could technically leave it like this because that is an equation for it. Let's clean it up though. So at the very least, we can just get rid of the minus and minuses. So it's 3/2 x plus 2 equals y plus 1. So now we didn't have to, but we're going to put it in slope-intercept form just so you can graph it at home and see that they look right. Although on your TI calculators, it might look a little wrong because, let me explain that. 2 parallel lines on your calculator graphing window might not look perfectly perpendicular because your window actually stretches out the x-axis. So if you go into zoom and you go zoom z-square, it will prevent that. You'll notice like if you graph a circle on your calculator, it kind of looks like an ellipse. So just be warned, and I can explain that further if you ever need me to. Okay, so let's solve that thing for y. Just distribute the 3/2, 3/2 x plus 3 equals y plus 1, and then subtract 1 from both sides. You get y equals 3/2 x plus 2. Okay, so you can punch that in your calculator and go ahead and graph it. And remember, the reason we like graphs is because you should know what your line is supposed to look like. And if it looks wrong, you did something wrong. Looks right? Goes through the point we want and looks like it's perfectly perpendicular to the original line. Okay, that's all. Thank you.